Welcome back. In this section, the first thing, the base resolution is going to be 100 and the size is going to be the same, but the boundary is going to be none, minus y, and none. Y minus y, because of the y is upward, downward is going to be the minus y because of we are having an interaction with this ground, right? Now, content method, we don't need to change anything in here. So close this and the display. In this display section, we need to have this boundary draw, right? Every option is not important for all the cases, right? So there is a 80-20 principle in every feature of your life, right? So in this section also, each and every option is not required to demonstrate. So now we have this boundary draw we have here, make it none. That means is what that we don't have any boundary, but it is still exists, but we cannot see that. Cool. And now we need to have that dynamic simulation. And in this dynamic simulation, we need to have this viscosity. What is viscosity means? Viscosity means is that the air is going to give you the pressure from the outside. So the exact the same thing that when the smoke is rising upward, downward, here and there, the atmospheric air is going to be suppressing down that thing, right? So this is called viscosity. So I can make a viscosity and very, very little amount. And here we have dampening. Dampening is also very important. But what is dampening? Dampening means like a fall off kind of thing. So that energy is there and it is slowly going down, and the action, everything should slow down, right? So like an attenuation kind of thing, like decay kind of thing, you can say. Yeah, a perfect word is attenuation or decay. Over a time, it is going to be very, very slow or settle down every action we have. So this is called dampening, right? And you have here that high detail solve and make it all grid. That means is what that high detail solve means is what that of course we need high detail solve. Who is going to be having a desire of getting a low detail solve, right? So all grid means is what that each and every option that we are going to use in this section, we are going to get that in that simulation, because of that is what we are telling to that container that high detail solve means all the grid I'm using, right? Now here we have this simulation rate scale. Simulation rate scale means is what is a very, very very interesting and very important aspect of this same thing. Make it 0.5 because of it will make the simulation slower, all right? But it is affecting the external feature also. So suppose if I using this something called, like if I go to effects, and this is, suppose I'm using gravity or volume axis field or anything, air, anything. So this is also be affected by this thing. So this is a very, very unique thing that suppose you are using gravity or you are using this vortex. Suppose you are using this thing and you are increasing the amount of vortex, all right, and you are decreasing amount of this simulation rate scale. Your vortex is not going to be prominent in that scenario. Why so? Because the vortex is happening in the simulation and the simulation rate scale is very, very lower. So that means is what that if you are using this thing, every external forces or anything is like simulation is going to be slower no matter what we are going to use, right? So this is very, very, very important that because of I'll tell you when I'm going to use this volume axis field in the later video that how we're going to use this thing. So first thing, that simulation rate scale A is going to slower or make it a faster your simulation, right? So this is how we have to set up your dynamic simulation category. In the next one, I will show you that how we're going to use all these options in order to get a nicer look. But for this section, we have done dynamic simulation, and see you in the next lecture.